All right, we got a simple correlation problem for you. I made up some numbers that show a relationship between self-esteem and happiness. It appears that as self-esteem goes up, so does happiness in this example. So first things first, we have to make sure that when you enter these variables, they are continuous. Dependent variables are continuous. To do a correlation, you need two continuous variables. Otherwise, it won't work. They are both set to continuous, okay? Right here, make sure they are continuous. Now I'm going to hide those variables. Click regression. Click correlation matrix. Click in the variables you want to run correlations on. You can click in more than two. You can run more than one correlation at a time, but we're just learning correlation today, so how do we find that value? Number one, it's beautiful. We already see our correlation value is 0.96, and our p-value is significant less than 0.001. What is the effect size for a correlation? Now, this is actually interesting. So I'm going to teach you two ways, okay? And I want you to know both. The first way I'm going to teach you is you square your correlation coefficient. So 0.96 times 0.96 is let's give that a shot. Let's just make sure 0.96 times 0.96 is 0.9216. So what does that mean? That means 92.16% of the variability in happiness is associated with variability in self-esteem, or 92.16% of the variability in self-esteem is associated with the variability in happiness. Or you just say shared relationship. These two variables shared 92.16% of overlap or variation or variability. I don't care however you say it, but you see that. Like, oh, they share 92%. Their scores are 92% related. 92.16 in this case, right? So that's R squared. And that's my favorite effect size for a correlation. So an R squared of 0.01, which is 1%, is small. All R squared of 0.09, which is 9%, is medium. Or an R squared of 0.25 is 25%, which is considered large. Now, if you're good at math, you take the square root of those numbers. You know that R of 0.1 is small, R of 0.3 is medium, and R of 0.5 is large. You're going to have to write those down. I don't have them, well, they're written in a little bit, but you're still going to have to write them down, okay? So this technically is a large correlation. It's greater than the 25% that we were talking about. It's greater than a correlation of 0.5. The correlation is 0.96. Okay, you're going to need a few extra things. First, you're going to need to know the number of observations that went into the correlation, number of pairs of observations that went into the correlation. That is 10. The degrees of freedom for a correlation are always 10 minus 2. And that's going to need to go in parentheses. So the degrees of freedom for this problem is 8. Okay? I'm going to show you one more thing. The 95% confidence interval of this correlation suggests that the true population correlation could range to be anything from 0.83 to 0.99. If we take 0.83 and square that, let's do that real quick. That's suggesting that 68.89% of, these two variables could be related to 68.89%. The variability in self-esteem could be 68.89% associated with variability in happiness and so forth. All that stuff I was talking about earlier. From the percentage scale, a large correlation, 25% is considered large. 9% is considered medium and 1% is considered large. So our 95% confidence interval suggests that this could be a large to large effect. We know that this correlation is large. We know that for a fact. Okay, worst case scenario, the two variables are related. That 68.89% that I was just talking about. Best case scenario, they're basically 100% related. All right. So we need to just remember that this is optional, but 95% of 95% confidence intervals contain the true population value. I'm going to write that down for later because I'm probably going to include it. 0.83, 0.99 in my write-up. Now there's one more thing. You want to look at the plot. I should have clicked that a long time ago just to look at it, but we can see, has self-esteem. I don't understand necessarily the the drawing here, it looks a little weird, doesn't it? But essentially, we know that as self-esteem scores rise, so do happiness scores. And we know that our happiness scores range to 4 and our self-esteem scores ranged a little bit higher, 1 to 10. So we can see that this is telling us that this is self-esteem, and this right here is telling us this is happiness. So as self-esteem increases, happiness also increases. We can see that. As self-esteem increases, happiness increases. As happiness decreases, self-esteem also, because self-esteem's here. So as happiness decreases, self-esteem goes from 10 to 7 to 5 to 2 to 1. As self-esteem increases, it goes from 2 to 5, and happiness goes from 1 to 2. As it goes from 5 to 5.7, and self-esteem does, happiness goes from 2 to 3, and as self-esteem goes from 7.5 to 10, we can see that happiness goes from 3 to 4. So that is beautiful and super simple, and that's everything we need for our output. Those are our first kind of steps. What's our interpretation here? Well, this is a large and significant effect. That's what we see, right? That's our interpretation. Even when we have the 95% confidence interval to tell us what the true population correlation is, we still have the same interpretation. We are fairly certain that this is a large and significant correlation based on this data. What that means is that the true population correlation is likely to be a large correlation. The true population correlation is not 0. The null, that there is no correlation. So we're saying that's not the case. And we're also saying the true population correlation likely lies between 0.83 and 0.99. How do we write this up? Let me pull up my PowerPoint slide really quick. Self-esteem and happiness are significantly correlated. R is with 8 degrees of freedom equals 0.96. Positive 0.96. Our P is less than 0.01. 0.6% of the variation in happiness scores is associated with variation in self-esteem scores, making this correlation quite large. Mental note, as self-esteem increases, happiness increases, or as happiness increases, self-esteem increases. That's shown right here in the positive correlation. We also can add our 95% confidence interval, 0.83 to 0.99. That's optional. I love 95% confidence intervals. If they don't make sense to you, don't use them. If you want them to make sense, come see me during office hours. But that is basically perfect. Now a small R squared of 2. So I'll just go ahead and show you that. R squared. If R squared equals 1%, it's small. 9% is medium. 25% it's large, right? If R by itself, and they should be lowercase, okay? If R equals 0.1, it's small. If R equals 0.3, it's medium. And R equals 0.5, it's large. So this is a 95% confidence interval of R. It's going from it's saying like 0.83 to 0.99. Both are greater than large. So we're fairly certain that the true population correlation in this example is large, right? There is a difference. The population correlation is not 0. That's all we learned from our p-value. The population correlation is not 0, right? And when we add that 95% confidence interval, we can see that true population correlation is likely large when I add it. If we didn't add it, we would still say, well, it's a significant and it's a large difference because, R squared 92.16 is greater than 25%, or our R of 0.96 is greater than 0.5. I talked to you about that. I tried to make sense of that. But essentially, that's how you run a correlation. Now, your turn. Run this data. Pause the video and run this data. Pause it. I'm going to show you the answer in a second. Make sure you turn in the right answer for your homework. All right. So now I'm back. I'm going to give you the answer. We only had 7 observations. And it went from 4, 4, 4 to 2, 2 to 1. Now, this is, I just changed the data. And what I love, you can see that my Jamovi just auto-updated, right? So what do we know here? We know that my Pearson correlation is a negative 0.92. So as happiness, as self-esteem increases, happiness decreases. Or has happiness increases, right? As we get higher and higher in happiness, self-esteem decreases. Remember, this is self-esteem, this is happiness. It's probably the worst labeled graph in all of Jamovi, but it's free, it's easy, it makes sense to us. So this is a significant and a large effect. We can tell that. So it's significant, it's a large effect. So essentially what that means, the large effect here, right? We square this 0.92. 0.92 squared. Let's figure out what that is. All right. 0.92 times 0.92. 0.8464. So 84.64%. 84.64% of what? So the way I'm looking at it is happiness is my dependent variable. 84.64% of the variation in happiness scores is associated with variation in self-esteem scores. Or if you just want to say happiness and self-esteem scores are 84.64% related. I'm fine with that, right? That is a massively large effect. When we're looking at our 95% confidence interval, we know that the true population correlation likely falls somewhere between a negative 0.56 and a negative 0.99. Now, if we squared negative 0.56, it's greater than 25%. We squared negative 0.99, it's nearly 100%. So we know this is a large correlation as well. I made up the data. The p-value is 0.003. The degrees of freedom are 7 minus 2, which is 5. And ultimately, this is the answer for that problem. Let me just make sure I entered it correctly. Did I enter the data correctly? 444, 222, and 1. Let me go back to the data. 444, 222, and 1. So yes, we did enter that correctly. These are the results. When you write it up, you would just put in it's basically the same interpretation. But for here, right, what are the two variables? Are they significantly related? What's the Pearson correlation value? What's the degrees of freedom? What's the actual value? 95% confidence interval, p-value, r squared, converted to a percentage, which you won't really need to do forever, but I'm making you do it so you understand what a correlation means. It means that for this example, based on my notes, 84.64% of the variability in self-esteem is associated with happiness. You can see all the effect size interpretations down here. Mental note for this one, it's a negative correlation, so as self-esteem increases, happiness decreases, or as happiness increases, self-esteem decreases. Either way is fine. But ultimately, that's it. That's your answer, and we are done. Good work. That's what you got to turn in, though, for credit.